For some famous theories in our acids and bases, at least three of them are normally mentioned, and one
Hmm.
of them by name. The primary theory of acid is that acids are H plus donor. Now
Yeah.
we put the second concept. The second concept says that all acids are water soluble. Now, this is a very important concept. An acid behaves as an acid only when it is in water. Otherwise,
Yeah.
what is HCl? HCl is a gas. If you see HCl in pure form, you will be surprised that it is not an acid. HCl is a gas. What is H2SO4? H2SO4 is actually H2SO4 is sulfuric acid, and H2SO4 is basically a fuming liquid. Now, let's make our some common names. You have to memorize. Chemistry is memory. So
Hmm.
HCl,
Hmm. Hmm.
HCl, H2SO4, HNO3, the famous three leading acids in our course, which are
Yeah.
considered strong acid. And then
Sorry, 1 second. I'm gonna write these important names in the front of my book so I can always go through them.
you
Just give me
want,
one
you
second.
can, but that's fine. But you can first try to memorize them.
Yeah.
First, we should revise that. Acha, H2CO3 is carbonic acid.
Yes.
H3O4 is phosphoric acid. CH3COOH is acetic acid. And what are they? They are called weak acid.
Yes.
So try to memorize these names.
Sure.
Okay. So could you uh, memorize them?
Yes. I sh- I
If you
will
want,
be.
that's fine also. But main thing, when October is ending and it's hardly a 1 month game, the main thing is that whatever comes in line, memorize it, make a quota, suppose 10 questions per topic, and then roll over every topic because obviously the syllabus, whole syllabus has to be covered rather than one syllabus too much covered, one chapter is over covered. So that would be the real competition, that how you manage the time resource. Suppose you make a quota of 10 questions, or maybe you say 5 questions per topic, or some depending
Hmm.
upon the time allocation, and
Yeah.
you should try to make the whole syllabus in the days you have. According to that, you should make a plan. Mark
Yeah.
the questions on a PDF. So obviously, after this mock two will occur in February, and then will
Hmm.
be the final mock. Now,
Yes. I've just to update you, I have done what you said. You said that to like this quota thing. I have done all the full revision questions for the for unit one, which is principles of chemistry, except
mm,
electrolysis, which I put in the list. And
mm,
also I've done organic. I am very like I said, I finished all the questions from all the lessons in organic and
once you
majority in 1C, 1CR. I just have to do 2C, 2CR for organic, and then I'll be done.
and you are saying that you have done the both the topical books. I mean, there are total 4 PDFs you have.
Yeah, so I've done this is for I've done topical books for 2015 to 2019. But you said through 2023 to 2019, 2023, right? Because new session.
I have said both of them.
Yeah. So I finished 2015, 2019. So now this week, like I said, I have holiday. I will get started on 2019, 2023 for
Mm.
organic and principles of chemistry because those two topics I'm confident with. For inorganic, me and you, we can do like before we doing past paper questions on like together, right? We can do that for inorganic because that I'm like weekend.
Because the rule is simple. There are 4 books. They cover 2015 to 2023, around
Hmm.
8 years or 9 years, like that.
Hmm.
So this depends upon the time availability, and obviously organic is a one of the biggest milestone. And if that is covered, that's a very good news. And
Hmm.
let's see how much marks you get in that organic test,
Yeah.
because that will be our first. We have to see where our weakness is there. Let's put our third concept. Acids are classified in two main branches: strong acids and weak acids. The weak acids are those which ionizes
Completely.
partially. Strong acids are those which ionizes completely, and weak acids are those which ionizes partially. So this is a weak acid, CH3COOH. It is the same acid which is in use in vinegar, in soups. It is also used indirectly in our soft drinks like cold drinks. Now look
Yeah.
at this.
Wait,
The
what is the word ionize means like dissolves completely.
ionization means it breaks into ions.
Okay.
Look at, I'm writing the equation also.
Hmm.
And if you see this equation, you will identify what is ionization. Ionization means that a compound breaks down into ions. That a compound breaks down into ions.
Hmm.
Now, you have to memorize this. Can you repeat now? What are strong acids?
Strong acids are acids that ionize completely, and
Hmm.
weak acids are acids that ionize partially. And ionization is how a compound breaks down.
Yes, it's basically breaking down into ions. Now, we come to our next concept, bases. What are bases? This is a rough approach, but it works. That bases are OH minus donor. Bases are not all soluble in water. Some of them are soluble. Now we make a concept that water soluble bases are called alkalis. Some bases are soluble in water and some bases are not soluble in water. So we have a
Hmm.
concept, water soluble bases are called alkalis. Water soluble bases are called alkalis. So repeat the concept.
Water
Bases are
soluble
those
bases are called alkali.
which give you OH minus.
Yes.
Bases are those which give you
OH
OH.
minus.
And what are alkalis? Alkalis are those which are soluble in water. Now, what are alkalis? They release OH minus, which is hydroxide ion in solution. Equations are very important. NaOH, one of the most powerful alkali in our lab.
Sodium hydroxide.
Hmm, it is as dangerous as acid, because this is a very common myth that alkalis are not dangerous. Actually, acids got a lot of fame, but alkalis are strong alkalis are as dangerous as an acid. Now look at the ionic equation. It breaks into Na plus and OH minus. Second, ammonia is a mild base. Alkalis are water soluble bases. Now absorb these equations. Equation is very important.
Hmm.
Equations are really very important.
So you see how there's sodium hydroxide, and below it's what is NH3?
Ammonia.
That's ammonia or ammonium,
No. NH3 is ammonia.
and NH4 plus
NH4,
is ammonium.
NH4
Okay.
plus is ammonia.
Okay. So in the second one, NH3 plus H2O, is that a weak alkali?
Hmm?
Is the second equation showing a weak alkali?
Yes,
Okay.
ammonia is a weak alkali.
So does that mean the pH of it will be towards the center of the pH scale? Like it won't
Yeah.
have, you know how the pH there's 0
Uh,
and the 7
no,
and
no,
there's 14, right?
no.
So
Vice
will it
versa.
be like 8 or
The
9?
point which scale is 0 till 7 and then 7 till 14. But what was
Yeah.
the question?
I said, will ammonia be towards like 6, like 8 or
Acha, acha.
9?
Ammonia will be close to 7.
Okay.
It will
Because it's
cross
very weak.
7. Like NaOH is somewhere around 14.
Because it's very strong. It's strongest.
All bases are not soluble in water. Now comes the list. Acha, the same rule applies here, that alkalis are also in the same fashion, that alkalis are also classified as weak and strong. This is a common classification which comes every time. And
Hmm.
whenever talk about an acid or you talk about a base, you will have a common thing. And that's why when you enter a lab, and suppose you are dealing with acid or a base, okay, the
Hmm.
first the the first thing the instructor will tell you, a professional instructor, that look, this is a strong acid, be
Yeah.
very careful, a single drop should not touch you, and it can cause, otherwise it can cause a serious problem. So alkalis are similarly very dangerous, strong, and weak, the same classification.
Yeah.
The same rule, when they say strong, they ionize, or the word we use sometime is dissociate completely. They fully ionize, and when you get them into water, they can release 100% of their ions, and that is why their aqueous solution is very concentrated and simultaneously very dangerous. Now you sometimes examiner asked to write down the state symbols. So for them, as alkalis or acids, you write aqueous. Aqueous means in water. Then what are weak? They ionize, or the word is,
Disassociate.
yes, dissociate partially. So they are not that much dangerous, because the main working, the main behavior of an acid or an alkali comes in when it is meeting and ionizing in water. So
Yeah.
water, ammonium, ammonia plus water gives you NH4 plus. NH4 plus means ammonium ion,
Hmm.
and this is OH minus. So please absorb this, that there are two types of acid. There are two types of acid. One is called
One is called weak acid.
strong
One is
and
called,
weak.
yeah,
Similarly, there are two types of,
alkali or base, and one is strong and one is weak.
but make this clear, the word strong and weak is used for alkalis. That's the main important thing. Bases are not soluble in water. Bases are
Yeah. No, but
not,
it says you said all bases are not soluble in water.
the bases
So,
which are not soluble in water, the bases which are not soluble in water, they have no question of ionization.
hmm.
Okay, acha, I forgot to show you the state symbols for water. For ammonia, it's a gas. For water, it is a liquid.
Yes.
Ammonium is aqueous, and OH is also aqueous. State
So
symbols,
basically, that's the theory behind like the strong bases and strong acids is because they ionize completely. There's more
yes.
concentration, so that means there'll be like more of the
More
acid
ions
present.
or more alkali ions, so their behavior is more prominent. You must have heard about a lot of safety precautions against these acids, especially because the H plus ions actually can react quickly, because if they are used in the strong way, it means there are a lot of H plus ions. Further,
Hmm.
will find in your exam, they use the word dilute or concentrated. Dilute means more water, and
Hmm.
concentrated means less water. When you make a soup at home, when you make any drink at home, suppose you want to make a sugar drink, so you add some sugar in water. This is the start of the solution. If you add a lot of sugar, some people take a lot of sugar in tea, so we say
Hmm.
this is concentrated. If you have a taste of sweets, some people like sweets a lot, they feel a craving, Why? Because of the concentration.
Yes.
Concentration is a term used when we use this chapter, that it's the amount of solute in a solution. Now let us see the
Mm.
next. Alkalis. The first two are strong and the next two are weak. You have to memorize them. It's better if you copy them. These names are important.
Yeah.
I'm just coming in a minute. Copy these names.
Sure.
Reaction between acid and alkalis. This is the title reaction. Word equations are game changers, and I always advise my students that use your own hand, your own memory. Take a piece of some sheets, maybe two, three sheets are fine, and write
Mm.
down all the word equations whenever they come across you in your own writing. So definitely, already some made notes are there, but
Mm.
have a tested in my experience. Notes have a very important attachment when you have written in your own hand. Digital
Mm.
notes are just like the artificial appearance. They never make a link with your brain. So this is like acid plus base give you salt and water, one of the most repeating equation in our course, exam course. Acid
Mm.
plus base give you salt and water, like HCl plus NaOH give you NaCl plus water. H2SO4 plus 2KOH, K2SO4 plus water.
Yes.
HNO3 plus NaOH. If you remember the word equation, you can write all of them. This reaction is called neutralization. Interestingly, in all these reactions, there is actually a common feature, that H plus, the H plus from acid, this one H plus, and OH minus from the alkali are actually making water. So all the above reactions have a common ionic equation. All acid reactions, all acid-base reactions have a common ionic equation. What is the common ionic equation? H plus O
OH.
minus gives you H2O. So this is to memorize. Now from the point, what is the word equation?
It's
Acid.
acid plus base forms salt and water, and it's
Yes.
neutralization.
And there are many examples. They are called neutralization. What is the summarized equation?
H plus O H minus gives you H2O.
Yes. Now these are the word equations for acids. They really need to be memorized. Acid plus base gives you salt plus water. Acid plus reactive metal, group 1, group 2, I mean.
Hmm.
Salt plus hydrogen gas. Acid plus metal oxide. Metal salt plus water. Acid plus carbonate. Salt plus carbon dioxide plus water. Now, try to memorize them. That is important to memorize.
Hmm.
Okay.
When you say reactive metal, so if it
Hmm.
if we react an acid with gold, what would happen? Nothing.
If we react,
Acid, let's just say hydrochloric acid with gold.
acha, this is an extra question. This is first of all, the point is that gold is a inert metal, one of the
Hmm.
most inert metals. Sometimes a student asked me a very good question in a higher level class, and she said that why gold has become a benchmark for wealth and everything, and from chemistry point of view. So I told
Hmm.
her that look, gold is the most inert metal. So it means when you buy gold, it will never deteriorate. For example, if you buy 1 kg of iron, it will gradually depreciate. It will gradually rust out. This is
Hmm.
as a rule of economy. It's going down. So gold is inert, one of the most inert metals. So theoretically, HCl won't do anything. There is a combination of acid, one of the most dangerous mixture of acids, which is called aqua regia, that can actually react with gold. But obviously, who will be so mad to try to dissolve gold in an acid?
Yeah.
But obviously, that require just like a little piece of gold some people use. But as a rule, in the reactivity series, which is one of the most important series to memorize in O-level chemistry, you will see gold is very, very low in the series. Gold, silver, platinum are the permanent member of this planet. And that is
Hmm.
why gold has become a gold has become a tool,
Valuable.
human exchange in transactions. So if you have 1 kg gold, it's not going to be changed over centuries, because why? It is not rusting. That's all. The gold
Hmm.
is towards all the gold is inert towards all the common acids. Now we
Yes.
move to our next title, indicators. What are indicators?
They like describe it some things like they
Mhm.
show your pH and
Acid.
it changes color.
They are used to distinguish acid. To look at this concept, what are indicators? Like, what is the purpose of a car indicator? The purpose of a car indicator is to show that your car is turning at a point. So you have to use the same idea here, that
Hmm.
it is actually it is actually a compound. Normally, it's an organic compound which is used to show color changes. For example, litmus solution, phenolphthalein, methyl orange. These are the
Hmm.
famous indicators, and they are there to show you the color change, because you need something to identify, is it an acid or it is an alkali. So these are
Yeah.
the famous color changes. Obviously, You have to memorize a table, which I will send you. So you memorize these important colors.
Is
Litmus.
it possible to like look at what do you say, a liquid in a microscope and see the atoms?
No, this is again a question related to size. That presently in college level or university level, there is only one machine which is called the electron microscope. It can zoom it in that level that you can see an atom like a spot, but
Oh.
at not an entity like we are an entity or a microorganism. A lot of research has been made on it. Now we see that atom in our O level, I tell my students, look, atom is an illusion. Atom is not like a ball which you see on the ground and you can take a picture of it. Atom has no boundary. Atom
Hmm.
has no boundary. Huh? You can imagine to view a nucleus. Nucleus is solid, even though it doesn't have a boundary also. So when you see an apple, why you see an apple? Because apple has a boundary. Light absorb, reflect, and you see the apple. But why you can't see something in air like a air molecule? Because they do not actually exist like solid objects. So they
Hmm.
are actually, this is atom is like an illusion. And if you see the new videos, the new quantum videos, you will be fascinated that now we believe that atom is just like a collection of some nucleons and electrons are moving around them with the speed of light.
Yeah.
Now phenolphthalein, look at
This
the
is only
color.
for titration, right?
Ah, this is a very nice color. If you have done titration in school lab, then you can recall it.
Hmm. Yeah, we did.
Hmm. So this is actually a prominent pink color, and when you are dealing with an acid, you can always look up this color.
Hmm.
Look, another famous indicator, methyl orange.
Hmm. Isn't or is methyl orange an organic compound? Is that why it's called methyl?
Majority, this you have identified very good. This is a very good judgment. And if
Yeah.
you use organic in that way, you will actually identify that all the medicines you use, if you see their generic name now after studying organic, you will be
Hmm.
amazed that majority of them are organic.
Hmm.
And that's why they have such difficult names. And
Huh.
that's why
Yeah.
doctors writing is always in that way. So people make a joke that actually it is not easy to memorize the spelling, so they slash their writing. So the generic names are all organic. Even if you see the artificial foods, the synthetic fiber material, the artificial cloth, you will find all organic. If you go to a shop and you want to buy a shirt, you will see it's written on it polyester.
Hmm.
I mean, what is polyester? Polyester is actually an ice and basically a polymer of ester, and ester is an organic species. Now
Hmm.
give the heading pH scale.
Yeah.
What was the pH scale?
Huh? The pH scale is 0 to 14.
Sorry, 0 to 40. Now, what was the idea of making a pH scale? Scale is necessary to understand the calibration. For example, if you think very interestingly, this is a very interesting social science behavior which humans have developed, and now humans are trapped of it. Our education system, class 1 to now even KG1, KG2, 1, 2, 3, 4. If you imagine, it is nothing real. There is no reality of grade 1, grade 2, or any grade. We made
Hmm.
ourselves, and now there's a big debate going on across the world, especially in European countries, that what is the purpose of this scale, that around 22 years or 24 years people are studying. So a big amount of the age is gone in years. Now, what is this grading system? It's a scale.
Hmm.
Another example of the concept of scale is our Edexcel 9 to 1. 9 to 1 is a scale. So similarly, chemistry need a scale to calibrate the acids, that how we say it's strong and how we say it's weak. That is the theme behind the scale. pH scale is used to show acid, base, or neutral behavior. Then why we call
Hmm.
it pH? The letter P means power and H means hydrogen ions. So actually the pH means power of hydrogen ions. So you have given the heading pH, and
Hmm.
you have to memorize that pH is actually you have to memorize that pH is actually a scale used to calibrate the acids. And what this pH stands for, P stands for power, and H is equal to concentration
Of hydrogen atoms.
of hydrogen ions. Now,
Yeah, because wait. Why do we say hydrogen ion or hydrogen atom?
no, because hydrogen atom would not have a charge then. No,
Hydrogen atom is H2 and hydrogen ion
no,
is H plus.
no. Hydrogen atom would be simply H.
Oh.
Hydrogen atom would be simply H. When you say
Hmm.
H plus, you call it H plus ions. Another interesting name for them is proton. H plus ions are called protons. Imagine
Okay.
how or why H plus ions are being called proton.
Because it's positive.
No, because actually hydrogen has only one atom. Oh, sorry, hydrogen has only one proton in nucleus and one electron in the shell. It's one.
Hmm.
Na? If
Yeah.
hydrogen,
Oh, so when the electron is gone, it is just H plus. So only
yes,
positive. Yes. Okay.
yes, that is why H plus ions are called protons. So that is why a famous definition will come that actually acids are proton donor.
Donor. Yeah.
Acids are proton donors. And this is the definition which is very famous. Till A level it will come, and it is one of the most famous definition. Now comes
Yeah.
the
Wait.
zero.
Is H plus the I? No, that is hydrogen diatomic, like in the
Yes,
air.
hydrogen is always diatomic. It always survive in H2.
Hmm.
Like
Okay.
oxygen is diatomic. So
Okay.
hydrogen is always able to survive. Hydrogen is always able to survive in diatomic state.
You know when water is formed, H2 plus O2, right?
Hmm.
Where does the extra H go? Does it just go? Does it just be collected as gas?
No, actually, I couldn't get your question. When water is formed, H2 plus O2 gives you
Yeah,
H2.
H2O, and it gives you an extra hydrogen, right? Where does that extra hydrogen go?
No, no, it is not like that. H2 plus O2 means one molecule of hydrogen combined
Mhm.
with one molecule of oxygen, and one molecule of H2O is formed. The balancing is the same purpose. Now, your question is actually that
Uh,
why there is no 2 with oxygen, why it shouldn't be H2O2.
yeah.
But H2O2 also exists. This is heavy water. H2O2
Oh.
existing, it's H2O2 means heavy water. Actually, chemical bonding does not follow mathematical summation. So when you say H2, and this is another very famous joke, and sometimes people criticize chemistry that look, C plus O2 is sometimes CO2, and sometimes C plus O2 gives you CO. So chemistry is not balanced, but they say no, chemistry bonding is not like mathematical summation. So when you say how it is possible, the answer comes from the chapter called bonding. When CO
Hmm.
form, it is one carbon with two oxygen. When
Yeah.
CO is formed, one carbon with a triple bond of oxygen.
Carbon monoxide.
Yes, chemistry is not concerned with the balancing of atom numbers. It is always concerned with the balancing of their bonds. That is why in the second equation, you have to put a 2 here,
Hmm.
and then you have to put a 2 here. It means your
Okay.
question will be answered now that 2H2 plus O2 will give you 2H2O. If you
Yes.
understand concept, you will actually understand the concept of balancing. Your question was that how it is possible that H2O2 gives you H2O. So what happened to one oxygen? Why there are two? Why there are no two oxygens?
Hmm.
Actually, you're not getting one molecule of water. You're getting two molecules of water.
Oh, so it's like all like it's factored into it. Understood.
Now you can balance and you can settle your query. So it means H2 plus O2. When I write H2O, there is a question mark that what happened to the second oxygen? Answer
It's
is simple. The
it's
chemical.
actually four hydrogen plus two
Hmm.
plus one oxygen. Okay.
So it is just like a ratio. It is
Mm.
just like a ratio. And in a joke, when people criticize these people of chemistry, they say, okay, fine, I give you four trees, will make four tables out of it. You say, no, four trees can be used to make maybe 100 tables. Four trees can be maybe used to make 50 chairs because tree is a different structure and chair is a different structure. Similarly, they
Mm.
say when carbon and oxygen combine to form carbon dioxide, it is not an extension of carbon and oxygen. It is a totally new entity. So as just like 100 trees, 100 wood trees can make maybe 500 benches. So similarly, it is not in the ratio of the atoms, it is in the ratio of the bonds.
Mm.
So now we
Sorry,
have
again, one more query I have. This is from organic.
Hmm.
It's about incomplete and complete combustion. Just when you wrote that, it came to my head.
Hmm.
If we were to perform an experiment about incomplete combustion, right, where we
Yes.
provided limited oxygen to the like system, would it would the and we produced carbon monoxide, how much carbon monoxide would it be until we die?
That's not a relevant question. Die.
I'm trying to kill my chemistry teacher. So
Not a good. That's not a good question. Uh, actually, carbon monoxide can cause unconsciousness, and
mm,
there is always a ratio. Again, chemistry is a logical science. It depends
mm,
upon the case that carboxyhemoglobin stop the oxygen transport, and then the problem comes first with the brain. That brain cannot get the oxygen. Now, the
yeah.
question is simple that how long brain can survive without oxygen. So what the brain does, look at the smartness of nature. When you get into such a trouble, what brain does, brain shut down the body just like a PC under over voltage nowadays or battery weak. What a laptop, good laptops do, they have a software in them, and if the battery is going extremely low, they shut down the system. So brain does
Mm,
the same thing. Brain shut down the system, and we call it unconsciousness. Then
yeah.
try to extract all the oxygen traces from the body to survive. And after that, then the brain can obviously go in a problem. So that is a long
Okay.
process. Carbon monoxide is not that much lethal. Huh, if someone is, may God not, in a trench or in a tunnel and fire breaks out, or may God not, someone trapped in a burning area, then this problem is.
Mm, okay.
And now look at here, this is a neutral disposition. Acidity increases towards left and basicity increases towards right. So you have to now copy this scale.
I copied it.
Good. And now you have to mark the strong and weak locations.
Yes. So you know how acid and base is neutralization, right? So that the product that's formed, that salt and water, is that completely neutral?
Now that's another very good question. Now this is a good question. So it is possible that we can say that it should be in a ratio. So when you say HCl plus NaOH, it's 1:1. If you put more acid, you put 2 moles of HCl against 1 mole, then final solution will be acidic.
Hmm.
If you put 2 moles of NaOH with 1 mole of HCl, the final solution will be alkaline.
Hmm.
So it's not a rule that you put some acid, some base, and they will neutralize. No, that will be even more dangerous. That's why
Yes.
in all good chemistry lab, a very interesting precaution is there that if acid spills over somewhere, never put alkali on that. Because
Hmm.
many people think alkali is neutralizing. No, because if you put more alkali than acid needs, it will be overall alkaline. If you put
Yeah.
less alkali than needed, it will be still acidic.
Okay.
Hydrochloric acid is a strong acid. Look at this. Hydrochloric acid is a strong acid, while citric acid is a weak acid and it's found in
Fruits.
lemon, etc. NaOH, look at this deadly compound. These are the crystals NaOH. NaOH is strongly alkaline, and then look at this shape. We make NaOH solution and we store it in a proper way. So for the safety purpose. This is universal indicator story. Universal indicator is a mixture which can identify nearly all the pH separately. So this is
Hmm.
the color change. Universal indicator alone can identify all the pH values. These are the separate pH values of universal indicators. So we have done the basic introduction of
Hmm.
acid and bases, their main reactions, and now we can go for titration.
Yeah. Titration, it involves salt forming and like we have to experiments, right? Or is that the next chapter?
Huh. Titration, basically, titration is an experimental technique, and
Hmm.
this comes under the title of experimental heading. And you have done, I think you told me you have done titration in school.
Yeah.
So, I think I had shared some videos also on that topic. So now
Hmm.
give heading titration.
Yeah. Okay. I did. This is the chapter where you do like find the amount of moles and stuff, right?
Hmm.
To neutralize the base.
So what is titration? First, make a concept. Titration is an experimental technique used to determine the concentration of an acid or alkali. Okay, what's the first concept?
It's an experimental technique used to determine the concentration of an alkali or acid.
Yes.
I have to ask, wait, do we have to draw any diagrams in the exam?
In the paper, there are questions which ask to complete the diagram, but they are very few. Now, just like some questions come, draw the distillation apparatus, draw a syringe, etc. So
Hmm.
some indirect questions are there in the new papers.
Okay, because when I was doing principles of chemistry, our teacher made us draw all the separating methods,
All the separate.
all the separation. You know the methods of separation. There's a chapter in principles of chemistry.
Mm-hmm. So
My teachers made like me draw like all the fractional distillation, simple distillation, all those methods we have to draw.
Acha.
Do I have to do that, or should I just know how it works?
No, but that's a good practice because this is something good. This you're talking about grade 9, perhaps, right?
Mm-hmm.
So that's a good practice. In grade 9, you have time. You can take the students to the lab. You can tell them to draw the apparatus. Normally, in the new paper, apparatus does not come as a complete work. But as
Mm,
with passage of time, the problem is coming that schools are doing less practical, which is now Edexcel is complaining also. Schools are
mm.
supposed to do a good number of practicals. I think I shared a PDF with you with links
Yeah,
also.
you said that
And
from
now it
Cambridge.
is also making a type of compromise. Okay, fine. Then if schools are not doing it, they take cover from the video. but a video can never obviously replace a real experiment. So this is the problem. If your teacher had asked you to draw filtration and other things, I think it's a good exercise because at least you remember them, no? Otherwise,
Yeah.
if you have not done the lab, if you have not drawn the apparatus, then you are only visualizing. And if they
Yeah.
ask you to add a condenser, for example, or add a syringe, even that can become a problem.
Yeah.
Titration can be used to create salt. Now look at these three important concepts. What are titrations? Titration is an experimental technique used to determine the concentration of an acid or alkali. Titration can also be used to calculate the number of moles in a
Given
given
solution.
solution. Titration can also be used to create salt.
So
Look at these bullets, and you have to memorize these three important bullets. That what are the important applications of titration? So can you repeat?
titrations are it's an experimental technique used to determine the concentration of acid or alkali. It's used to calculate number of moles in a given solution, and it's used to create salts.
Yes.
When it's
Salt.
when we make salt, that's always neutralization, right?
That's a good question. Salts are not always formed by neutralization. Salts can be produced by other reactions also, like acid and a metal. When they react, they create salt. When even you react a carbonate with an acid, you make salt. Salts are produced in a number of processes.
Is magnesium chloride a salt?
Yes,
Okay.
simple. Magnesium is a metal. Magnesium is a group 2 metal. Chlorine is a group 7 non-metal. Metal non-metal is ionic. Normally, ionic are salt.
Okay.
Now, look at the screen. No need to copy anything. Can you recall how we do titration?
Okay. So we should use the pipette to fill the conical flask with alkali, and then we add a few drops of the indicator to the conical flask. It'll be colorless at this stage because it's an alkali, right? And after you add the no, in acid it's colorless, and in alkali it's color, right?
And then you keep on swirling
You
it.
keep on like dripping, you drip it until it changes color. If you put the liquid, if you put the what do you say? The indicator in the alkali, it will already be pink, and as you add the acid, it will turn colorless. If you done the opposite way, it will be colorless, and if you as you add the alkali, it'll become pink, right?
Yes.
Okay.
Now, the famous experiment, I had shown you this before. Normally, whenever we do titration, we always look for, whenever
Doesn't
we
matter.
do
The burette's the
titration,
long
we
thing,
always
right?
look for the options of an
Yeah.
acid.
The required practical we're going to look at is this is a bulb pipette, and it has been designed to measure exactly 25 centimetres cubed of solution when used correctly. Now we can put our pipette into our, now we don't know the concentration of this, remember, and we're going to place that in our burette. Now our burette is a graduated piece of glassware, so I raise my burette up just a little bit. Of the meniscus, that is 14 point on the first one. What I would now do, just to confirm that that was right, again, I would take a new sample of
So that was a color change, and we can, let me share this video with you again. And
yeah, in that one, she's using methyl orange, I think.
yes, and that's a good video. Somehow the video was not very clear. I think so, perhaps, but maybe I was feeling it that the okay. So
doesn't matter whether you put an acid or an alkali in the burette.
No, that's a very important question. If you are looking for the concentration of acid, if you are looking for the concentration of acid, it should be in burette. The unknown should be in the burette. Acid or base, whatever it is, the unknown should be in the burette.
Okay.
It means that it's not open, that you put anything in the burette. You have to memorize that you have to put a specific thing for which you are looking for the concentration.
Wait, can you just tell me, is the burette 50 to 0? Does it go from
Sorry.
50 to 0?
Hmm?
Does the burette go, the scale go from 50 at the top to 0, right?
Right. You have two types of burette available, 0 till 50 or 50 till 0. Even bigger are available depending upon the need. Now, phenolphthalein is often used, indicated due to a clear color change. Now, we come to our next concept. There are two types of concentration. One is called gram concentration, and second is called molar concentration. Now, copy this.
I haven't seen questions asking for gram concentration that much. I've mainly seen for molar concentration.
90% questions are on mole per dm cube, which is a common concentration unit. Now, concentration is always defined as, this is the formula list. Formula number 1, concentration is equal to number of mole upon volume. So N is equal to CV, which can be translated for that. Now, N is equal to number of moles, and you have to remember that 1 dm cube is equal to 1000 cm cube.
Centimeter cube.
You have to give us side heading formulas and copy this.
Yes. Okay, done.
Good. Now, look at the second. Gram concentration is mass of solute upon volume. Gram concentration is equal to molar concentration into molar mass. You have to copy this also. Gram concentration is not important.
And wait, this number of moles is equal to mass over mR, right?
Sorry.
For number of moles, it's mass over mR, right?
Number of mole is equal to mass upon mR, right?
Okay.
Now, this is a point to understand that this formula is the primary formula. Number of mole concentration is equal to number of moles upon volume. N is equal to CV. N is equal to CV. Concentration is actually a concept of, the concentration is a concept of amount of solute in a solution. You will listen, you will see this terminology, concentrated HCl and dilute HCl. Concentrated HCl is very much more effective in reaction. It gives a faster reaction.
Yes.
Concentrated HCl gives a much faster reaction. So we have done majority of the acid bases. We have to do now calculations. So I think we can give one more class on it for calculation, and then we can do the past paper questions on this topic. You can update the list later also, but we are right now for that list, and we will shift from chemistry to other subject as we finish one topic in chemistry, as we hopefully finishing in the next class. Then we can do that other topic for physics. We complete one topic there, and then we do other topic. In that way, we can patch up the whole topic.
Yeah.
Okay. So we are stopping here. Thank you.
Okay, thank you. Have a good day. See you on Tuesday.
Bye.
Bye-bye.